Hello students. Welcome to School Life YouTube channel. Today's topic is, does an atom have a color? So without wasting time, let's quickly start the video and learn. The color of atoms, a complex question. Atoms, the building blocks of matter, are often thought of as tiny, indivisible particles, but do atoms have color? The answer is not a simple yes or no. Atomic structure and color. Atoms are composed of protons, neutrons, and electrons. The arrangement of these particles determines the atom's properties, including its ability to absorb and emit light. When an atom absorbs energy, its electrons jump to higher energy levels. As these electrons return to their ground state, they release energy in the form of light. Emission spectra. The light emitted by atoms is characteristic of the atom's energy levels and can be used to identify the element. This is known as the emission spectrum. Each element has a unique emission spectrum, which can be thought of as a fingerprint. Color and atomic spectra. The color we perceive is a result of the wavelengths of light emitted or reflected by an object. In the case of atoms, the emitted light can correspond to specific colors. For example, 1. Sodium emits a yellow-orange light. 2. Emits a blue-green light. Do atoms have color? In a sense, atoms do have color, but it's not the same as the color we perceive with our eyes. The color of an atom is determined by its emission spectrum, which is a characteristic property of the element. Limitations of atomic color. However, there are some limitations to consider. 1. Individual atoms don't have color in the classical sense, as color is a property of bulk matter. 2. Aggregated atoms. When atoms are combined in a substance, their emission spectra can be affected by the interactions between atoms. Conclusion. In conclusion, atoms do have a characteristic emission spectrum that can be thought of as a form of color. However, this color is not directly observable and is a property of the atom's energy levels rather than a visual property. Implications. Understanding the emission spectra of atoms has significant implications for various fields, including 1. Spectroscopy, used to identify elements and analyze their properties. 2. Lighting. Understanding atomic emission spectra has led to the development of efficient lighting technologies. 3. Materials science. Knowledge of atomic emission spectra can inform the design of materials with specific optical properties. The study of atomic emission spectra continues to advance our understanding of the atomic world and its many applications.